Hi guys, my name is Ansi Broch. I'm the head of mobile here at Redshift Cybersecurity, and welcome back to another episode of Redshift's mobile pen testing training series. So in today's episode, we're going to be looking at insecure data storage and insecure application logs. Okay, so very important when doing data storage analysis. So looking for insecure data storage or clear test information in application logs is you first have to play with the application, and that's why we did dynamic analysis first. So you have to play around with the application, push all the buttons, input all the fields, store some credit card information as we did in our previous episode, just to generate that data, right? So the data gets stored wherever it needs to be stored. Okay. So if you remember from our static code analysis, we actually did see that data is being stored in clear text. So we actually saw the credit card number being stored in clear text, and perhaps also the username and password. So what we're going to do now is we're going to start with our data storage, and then we'll move on to application logs. And we're going to do ADB shell into the phone, and then SU for root. Now I'm already root on my device here. So your application's data is stored in data, then your application's name. Now if you're unsure what the name is, just cd to data and then data. Do an ls, and if there's way too many apps, you can do ls and then grep for a word that you know would be present in your mobile app. Okay, so in this case we know Redshift is present. So here we see we did a ls and a grep for Redshift, and we see that there is 2 Redshift applications. Now we want the Vapor application, so we're going to cd into com.redshift and then Vapor. Perfect. Now this is all the files that the application has created and stored. This is fairly default files. We don't really see more than this. Sometimes a developer would create an additional file, and it would be here next to shared prefs. But this is kind of the architecture that we would normally see. So let's start with shared prefs. Shared prefs usually has some interesting data in. So usually if there's any insecure data storage, it would be in your shared preference file. So let's cat our first file, and here we can already see there is a cookie. Cookies are considered sensitive information because we can do some malicious things with it, right? And here's also an IP address. Now depending on the IP address, the situation, your environment, it could also be classified as a sensitive data. So there we have our first findings. Now let's see what else is in shared prefs. We have our web view Chromium preferences. Nothing really in there that's sensitive. And a lot of times people ask me, how do you know whether a value is sensitive or not? And just think of it as, what can an attacker actually do with this? For example, Google Analytics also sometimes saves like cookies or these types of values in the files. Now, we can't really do anything about trying to Google things, but also an attacker can't harm your application with this data, right? So that's kind of how we think of it. So let's go into files, see if there's anything here. This is GamesBot. So let's cat GamesBot, and this is just all the games that we have. Interesting, perhaps we can actually add values in here for more games, or maybe we can have some free games then. Who knows? You should try it. Then we can go to our databases. How we view databases in ADB is we do SQL like 3 and then the database name, chain DB. So we do .tables, and we see the table stored in this database. A interesting one we can see right from the bat that we would be interested in is the card info. So let's do select all from card info. And remember your thing at the back. And this is clear text storage of credit card numbers or card information. You have your card number, your your CVV, expiry date, and who the card belongs to. So this is a vulnerability because it's sensitive data being stored in clear text. But interestingly enough, with credit card information being stored in clear text, it's also a PCI compliance issue, which is an additional layer of risk that your company is being exposed to. Okay, so let's see what else we have here. So tables, let's do select all from users. Now, it's not case sensitive, guys. It's just I like to do it this way because that's how I was taught. It's really not case sensitive. It's not necessary at all, but it's just the way I do it. So your select doesn't have to be in all caps. Here we see admin, and we know that that is a user, and we have tested that that works. So if we didn't find that hard-coded credentials in our code with our static code analysis, we can see it here, and we can actually access the app with it. So we have already accessed it, we have already played with it, but this data is actually stored from before you actually start playing with the app. It's still very important to start playing with the app first. Cool. So we have our clear text storage of credentials. Anything else that is interesting, we can select all from product. Okay, this is just all the games that's in here, so nothing that we can really do with that. Select all from game purchases. I misspelled that, so let's do select all from game purchases. So you can't actually backspace in here, it's giving issues, so let's just try that again. Game. Okay, so this just shows what games you have purchased. So if you purchase more games, you can try and figure out what this means. It's probably connected to this number over here, so perhaps we can add more numbers and perhaps get free games this way. Okay, so that is everything from in here. .exit. Okay, apologies, I do forget you cannot go back. So let's go to code cache. So usually most of these files we know there's not going to be data in them, but we do have to go through them, each and every one of them, because sometimes developers do make mistakes and they store things in random places. So just to make sure we go through every single one of these files. So let's go to web view. Let's see if there's anything here. Another way of doing this is ls-la, then you can see that that's one more word. So we'll go into cd crash, then backslash report, nothing in there. Oops. Crash pad. Okay, these are all files, so let's cat the settings. Okay, this just means that the data is encrypted, guys, if it looks like this. Go to attachments, nothing in there. And you'll pretty much see there's nothing really in the rest of these folders. So let's go back. Okay, we see image manager, disk cache, and Chromium. Let's do that one, and then we can move on to the next. So this seems like yes. So we can just chat that. Oops. Spell it correctly. Some information. You guys can just go through this, see if there's anything that can help you figure out the application or sensitive data. Okay. So So this is kind of what we'll do, guys. We'll go through each one of these. Okay, we can go to our cookies. It's not a directory. This is interesting because this seems like database queries, and the interesting thing of why that could be sensitive is it gives you an idea of how the coding architecture looks like, or how the application is developed. So just kind of gives you more information about the application. It's not a vulnerability in itself, or it could consider to be, but it's not as sensitive information. It's just you can use it to get an idea of how the application is constructed and its architecture. Okay. So now that we've gone through the application's data, we're going to exit and we're going to go through the application's logs. Now, before we go to our application logs, how would an attacker actually get your data? So if we store data insecurely on the phone, how would an attacker get it? So there's a few ways. This is why root detection is actually so important. If you don't have root detection and a user's phone is rooted, they can access this data, or jailbreak detection, they can access this data. With jailbreak detection on iOS, we just don't use ADB. We can use like objection to go through those files, but an user can actually get this data. So that's why we never do clear text storage of any data. We encrypt the data and we store the encryption key in the key store or the key chain, or if it's possible to store the sensitive data in the key store or key chain. That's what we considered security leading practice, and storing it this way. But what if a user, or not just if a user's phone is now rooted and somebody steals his phone, then the person who's stolen his phone can perhaps get access to his credentials. But also if a user installs a malicious application, then the malicious application can also access this data. So two scenarios there where it's actually bad, and why root detection is important. What if I do have root detection? Then it doesn't matter if it's clear text, right? No, because root detection, such as all of our security controls, is bypassable by an attacker who is motivated enough, with enough time on his hands, they can bypass it. We follow a security in-depth approach, so we have to have these layers. Now, an interesting thing with data storage, which is not as common, it's a more complex attack, is even though you have root detection and the phone is not rooted, okay, an attacker could still get this data in a scenario where the phone is not encrypted. He can load a custom bootloader and access that data. Okay, there are some things that have to be true. So, for example, things have to be enabled, but there's exploits for it. So your bootloader has to be enabled or unlocked. But there are exploits for it on certain phones. What does it mean if your phone is encrypted? That means if you have a password on your phone or a PIN. So if you do not have a password or a PIN on your phone's not encrypted in most cases. So an attacker can load a custom bootloader on your phone and get that data. Also, in some scenarios with backup, if you back up your phone, sometimes this data does get backup that's stored in your data storage, except if it's in the key store or keychain. That data doesn't get backup. So yes, much more complex attack, but we still don't do it, even if we have root detection. It's just a security leading practices. We follow our security in-depth approach. Okay. Now we're going to do our applications logs. So our applications logged, you don't need to be rooted on the phone. Your phone doesn't need to be rooted. You can still access those logs. So it's really important not to store sensitive information in your logs, because it's more easily accessible than insecure data storage would be. So we're going to do ADB logcat. Now we are capturing logs for the phone. You can also do, if you want to, ADB logcat and then grep for like Redshift or a sensitive password or admin or whatever. So let's log into the application now. Usually we see this mostly when logging into our application, so we haven't logged in yet, so there shouldn't be any sensitive data as of yet. Okay, so now right before I log into the application, I'm just going to do that just for me to be easier find easily find our data. So let's log into the application. Phone is rooted. Okay, let's just quickly bypass that root detection. Objection -G, and then well, first need to just get the application's name. UAI. Okay, objection -G com.redshift rs _ vapor training, and then explore. Sorry. Okay, we need to start Frida again, as we know that is how the Frida error looks like. Just searching for that tab. Just make a new one. So let's do the ADB way. So I've showed you in the previous video how to start your Frida with command line. So let's now ADB into the phone, and I'll show you how to start Frida that way. So we do ADB shell ls. We are root, so we go to, remember where we pushed Frida to, data local tmp, and here we see Frida, so we just do this Frida, and we started our Frida server. Okay, now we're going to do objection, run that, it starts the application, perfect. Android root disable. Great. Now we can go back to our logs. Okay, log in, continue, again making space, just so it's more easy to find. Admin, and login. Okay. So we see that the admin credentials were not stored or transferred in the logs. We can also just do logcat just to make sure that we didn't just miss it because it didn't use the word Redshift. Or we can also do logcat grep admin. Okay, here we see some admin being stored, but let's just do the ADB logcat. Okay, so let's go to where credit card information is. That's always interesting. It's admin 00. So our sensitive information here that we would look for is admin and our credit card number. We can go through this, see if we can find any data. Okay, haven't seen it yet. Let's go, we bought a token. Not seen anything yet. Let's go to our cards. Let's add a card. We'll call it ANSI. We'll do month, year, and CV number. Okay, before we add, we do the spaces. don't see anything as of yet. Let's buy a game, see if that does anything. Let's try and register a user. So we're going to do ANSI and we're going to do my password. ANSI, super secure, I know. Okay, let's register, see if any data is being passed. It says welcome ANSI. Didn't log me in. Let's see. Then next is ANSI. And we're gonna log in. Phone is rooted. Going to do Android root disable. And now we're gonna log in. Okay. So just to make sure once again that there is no sensitive data, we're going to look through this if we see any word of ANSI, and we can also do logcat grep for ANSI to see if it was present anywhere. So here we do see it. So if we go on top here, we do here see that the application did do ANSI. Now, suspicious if that is our username or our username and our password. Okay, so let's do ADB logcat, and we're going to switch off our application and restart our objection. So exit, restart our application. Android root disable. Okay, going to log in, continue. Going to register a new user that doesn't have the duplicate username and password. Currently we can't see if they're storing the password or the username, or both. So let's do username, redshift, password is password 1, and we register that user. Okay, so now we log in with redshift and password 1, and there we can see it. We have our username and our password stored in our application logs. So if an attacker were to be able to get access to our logs, we can then just use the redshift and password 1 to access, or the admin or ANSI that we saw earlier. So this application does have insecure logs. Great. So that is how we usually search for insecure data storage and sensitive information in our logs. So remember, any sensitive information stored in clear text in your application's logs or in your application's data storage is considered a vulnerability. It's actually considered a quite high risk vulnerability actually. So with our insecure data storage, remember we recommend that you encrypt your data and store your encryption key in the key store or key chain. And with our application logs, we just recommend not storing this data in your application logs. What also happens a lot of times is clients leave their requests and responses in your logs, and which is also a bad idea because you're giving the attacker an idea of how the requests and responses looks and how your application's architecture is constructed. So it's still considered sensitive information. We don't want to give an attacker more ideas or avenues of attack that he can explore. So that is it for this week's episode, and we'll see you next week for runtime security, which is screenshots. Cool. Hi, I am Ansie Broch, the head of mobile here at Redshift Cybersecurity. Our next episode in our mobile pen testing training series is available now on our YouTube channel. It covers insecure data storage and application logs, which is personally one of my favorite vulnerabilities to search for and exploit, so go give it a look.